Hey, I didn't see you there. Welcome to the Advanced Placement Physics video with Mr. Ralph Uebel. This time, we're going to be doing motion graphs. Enjoy!
Here we see Mr. Uebel in his car. He's about to drive to Sarah High School, the greatest school in the universe. But before he gets there, he passes a lake with a goose. As Mr. Uebel reaches the streetlight, a man appears. It's Dr. Vincent Mr. Mays, Principal Vincent Mays. He challenges Mr. Uebel to a race, and the winner of the race would be the principal of the greatest school in the universe. Mr. Uebel proceeds to cut his brakes and accelerate off. Ultimately, Mr. Uebel destroys Dr. Mr. Vincent Principal Mays in the race and becomes the brand new principal of Junipero Serra High School.
Even though it was clear that Mr. Uebel had won the race, Dr. Mays demanded a re-race because he believed Mr. Uebel was cheating. Luckily, there was a motion detector at the end of the track that recorded both Dr. Mays and Mr. Uebel's position during the course of the race. In order to explain to Dr. Mays how Mr. Uebel won the race, Mr. Uebel organized the motion detector's data into a position, velocity, and acceleration graph. Alright. We will begin plotting our data on these three graphs. The motion detector gives us data on where both races were on the track. We will plot this on the position graph. We will indicate the racers by assigning them colors. This dark blue will be Mr. Uebel. And for Dr. Mays, we will assign him this red. Okay, the position graph data is all we need to create the velocity and acceleration graphs. So we will start with that one first. So according to the motion detector's data, Mr. Uebel's position was increasing exponentially. This means that Mr. Uebel increases in displacement at a greater rate than Principal Mays as time increases. On the other hand, Dr. Mays' position was increasing constantly. This means that he travels the same distance at every time interval. Now that we have a position graph done, we'll move on to the velocity graph. We plot this graph by taking the slope at every point of the position graph. In calculus, this is called the derivative. Mr. Uebel's large increase in displacement indicates an increasing slope. Therefore, we draw a straight slanted line to represent an increasing velocity. The position graph indicates that Dr. Mays increases in distance uniformly at every time interval, which has to mean that his velocity remains the same throughout the race. To plot this, we draw a straight horizontal line to represent uniform velocity. Okay, moving on to our acceleration graph. We will now repeat the same process just like the previous graph, from when we transferred the information from the position graph onto the velocity graph. Because Mr. Uebel has an increasing velocity, that means his acceleration is uniform. So we draw that with a straight line. I have to redo that. Looking back at our velocity graph, we see that Dr. Mays travels at a constant velocity. This uniform velocity means that Dr. Mays travels with zero acceleration. So we represent this on the graph with a straight line on 0. There we go. Now that we have all of our information, it's time to analyze it. Our position graph tells us that Mr. Uebel is ahead of Dr. Mays for most of the recorded times, and that he is able to cover more ground in the same time as Dr. Mays, except Dr. Mays barely gets anywhere due to his low speed. Mr. Uebel is able to cover a larger distance in a short amount of time because his velocity is much greater than Dr. Mays at a certain point in time, which we can see when the two lines intersect on the velocity graph. Lastly, we can see that Dr. Mays has no acceleration compared to Mr. Uebel. This is represented by the line set above it, which is at a higher value. In order to further prove Mr. Uebel's victory over Dr. Mays, we can find the area under the curve of the velocity and acceleration graphs. The area under the acceleration graph indicates the change in velocity. We calculate this by multiplying the time and acceleration, which is also like the length times width of a rectangle. Although not drawn to scale, we can definitely say that Mr. Uebel's change in velocity is greater than Dr. May's, because zero acceleration multiplied by any amount of time traveled would amount to 0. The area under the velocity graphs indicate the total distance the drivers have traveled or the total displacement. For Mr. Uebel, we will use 1/2 of the total area or use the area of a triangle formula to calculate the area under the curve, which is the shaded blue area. And for Dr. Mays, we will use the area of a rectangle and shade this area red. I'll note on the side in baby blue the formulas I use to find the area under the curves.
With the power of physics and calculus, Mr. Uebel proved to Mr. Mays that he is the racing king and the greatest teacher in the universe. The end.